warahmatullahi wabarakatuh. Ladies and gentlemen, uh, uh, I will presentation my paper uh, with title utilization of turbine wastewater of mini hydropower plant with powerhouse integration design model using geographic information system for international conference for operation by Muhammad Khaidir from Hasanuddin University, major electrical engineering. Introduction: electrical energy is essential in the country. The need for electricity is primary for life. The increase the infrastructure and the economic development has influenced the amount of energy demand. Renewable energy support of mini hydropower plant has a very significant effect in providing national electricity, especially in rural and remote area. Science is the environmental friendly, sustainable, and the production costs are the optimal expensive. The development of mini hydropower plant is a strategic step in accelerating the growth of renewable energy based power plant, one of which the utilization of river flow and the height of water head as the main base in the generator. The application of mini hydropower plant in Indonesia has been widely promoted, especially the remote area. This is of Bailani Rohani, uh, which use genetic algorithm uh, to solve optimization problem in situations the reservoir where water cladding is regulated uh, through outflow in the reservoir, the inflow in powerhouse. This is by initial research by Shane Ngelian Go about the design of integration between reservoir in Japan with methodology particle swarm optimization method and formulation uh, the result of water optimization the reservoir which integrated integrates between reservoir to uh, result of the water optimization the reservoir which integrated between the reservoir to obtain the optimal amount of water. Different research was carried out by Sebastian Brough of Germany, optimization the regulation of the hydro pump for optimal distribution of electricity generation in the German electricity market. Uh, the research offer a new model in the form of the integrated powerhouse model, mini hydropower plant by utilizing turbine wastewater. Uh, the hypothesis that is born is the wastewater in a turbine generator has a water flow was value is still up enough to be utilized to drive a turbine generator. The indicator of the speed of wastewater, discharge water, and height. Methodology: powerhouse integrated model of mini hydropower plant. Uh, Per plant, figure 1, the mini hydropower plant chart with a single powerhouse. The powerhouse integrator model is as a model the researcher coupled to utilize of the wastewater of the first powerhouse turbine to be inserted into a penstock pipa in the 10 then integrated flower into the second powerhouse. The description of the model chart the researcher purpose so as follow. Figure 2 mini hydro power plant chart with to the powerhouse integration model. Uh, this is figure 3 analysis framework flow chart for determining of the optimal location of the second powerhouse. This is parameter analysis is the weighting using method. This is method scoring analysis is mapping using of geographic information system. This is of method scoring analysis in geographic information system. Then the next objective function power variable of parameter gravity, head and discharge Q out in a kilowatt. Uh, this is efficiency generator and efficiency turbine. Uh, uh, the next is parameter scoring analysis. Table 1, head potential score head potential score. 2, distance to powerhouse scoring, distance to load center scoring, forest condition scoring, height, Y accessibility, loss scoring, slope scoring, and soil texture scoring. Location mapping using geographic information system. This is a district Bungin figure. Moving figure, location and mapping to have variable related to the design of the design, as well as the location of the penstock. The map of the Bungin district in generator figure 1 as an initial basis of reference is shown as follow. This is figure 1, Bungin district map. Result. The result power net of the Bungin district total power 1,613.700 volt ampere atau 1,6 megawatt. This is electric consumption, domestic consumption, infrastructure lighting, and other lighting. B. Bungin the Mini-Hydropower plant profile. This is 3 megawatt. The water discharge is the 5,5 meter kubik per second, and the head is 70,9 meter, and the coordinate point this is and coordinate. Turbine wastewater discharge. The discharge the graph kurva provide information the lowest water flow 4,522 meter kubik per second from at a speed of the 1,132 meter per second, while the high water flow is 4,670 at speed of 1,169 meter per second. From 24 holes of measurement, the average discharge, which also refers to the mains side discharge quick effective 4,515 meter kubik per second. Power loss. This is a power loss losses. The descending strongly influences the power loss for the edge location, scanner to the center of the load. Length, resistance, losses, power load. Table show that the power losses is the positive linear to the distance of the channel and negative linear to the amount of power that transmitted to the load center. The most significant power loss in the head 10 head scenario with a value of 110,499 kW. Effective power 2760 kW with the crash in power racing in the load center 26/9/9,1 kW. Total power output integrated powerhouse head scenario P1 3.000 kW, P2 power 2 effective this is method effective, power total effective. Determine optimal location using scoring method. Uh, uh, the scoring method is applied to simulate the score value for location parameter is each point of the head scenario. Here are the results of the simulation for the optimal location of the second power. This is table simulation result using scoring method. The best location had 3 and had 6. This is total score. Had 6 26, had 3 30. So is the simulation using the scoring method in apples in the head 3 scenario become the most optimal location with a total scoring value of 30. The head 6 scenario is the second optimal location with total score of 28. From the simulation, the researcher only take to most optimal location. This is topography using geographic information system. Figure Baruka village, figure Baluka village, figure satellite emergency of H scenario, imagery of H scenario, figure geological map of location, and figure optimal location is head 3 and head 6. Conclusion: the integration design model of the powerhouse in the study produce of an effective total power output 4,71 megawatt. This value is higher compared to a mini hydropower plant with a single powerhouse model. Turbine discharge water capable of producing reliable water discharge, effective 4,515 meter kubik per second. The optimal location of the second powerhouse in the scenario head 3 with a head value 43 meter at an altitude of 500 meter above sea level in the coordinate with effective power output 1,71 megawatt. This model is promoting is a new model in planning the construction of a mini hydropower plant. This is a reference. Thank you very much for your attention. Assalamualaikum warahmatullahi wabarakatuh.